In this video, I'm going to demonstrate OLAP operations on shooting data. I'm going to use array as the data model to support OLAP operations. So I have earlier saved our cleaned data at this location. So now I'm going to load those. So shooting data have a set of attributes, and they all can be considered as dimension. We don't have a measure. We don't have sum, average, anything like that. So for the demonstration, I need a measurement. So I'm going to add a measure count to shooting data. So I create a count attributes, and for every row, I'm going to fill the number 1. So every observation is one individual count. And I will later need dplyr, so I'm going to load that. Next, I'm going to convert the shooting data to a multi-dimensional array. If you're using other languages, you're probably going to write a complex function to do the conversion. But in R, the apply family of functions are really handy. So earlier we have looked at examples of A, the typical apply, and the S apply. And today we're going to show that you can use T apply to apply a function on each non-empty group of values. And those groups are formed by different unique combinations of the levels of the factors that we have in the dataset. So in this example, for the purpose of easy readness, I'm only going to choose 4 factors as the dimensions for the cube, and those 4 are race, state, group age, and year. So my tapply function going to apply this function, which is sum over x, and x is this. So I'm going to find the total, the sum of the incidence over different combinations of those factors. Okay. So this simple function alone gave you a multi-dimensional array that's holds the sum of incidence over all different combinations of the 4 factors. So let's look at our shooting base cube, and this gives us the base cuboid in our cube. And the following OLAP operations will all be performed on these cuboids to generate other cuboids that make up the lattice. So let's first look at what our this multi-dimensional array. So we have 4 dimensions because in a 2-dimensional space we can only display 2 2-dimensional data as a table. So in the display, R slices our data into a set of slices to show our race and state incidence counts distribution by age group and year. So each different values of age group and year combinations going to show displayed multiple times to present the entire data in the dataset. What we notice is because we have now this tapply function creates different combinations over the levels of each of the 4 factors. Therefore, we have lots of NAs in our dataset. So we don't have any incidents. For example, age in 2015, with mature population, some states don't have any incidents. So we have lots of NAs. For the purpose of making this multidimensional data, we want to replace those NAs with 0. NA means there's no incidence, right? Replacing it with 0 makes sense. So I'm going to replace anything that's NA going to be filled with the value 0. And now looking at this, the cuboids, and we have a very neat set of multidimensional array that holds the count information. And we can look at the dimension names. For this, the base cuboid. A base cuboid, as you recall, should cover all the dimensions in the dataset. So we have race, state, age group, and year. So now we have made the data ready. It's a multidimensional array. And now we can try to use OLAP operations. So first, we're going to use to demonstrate how to slice. Remember, slice perform a selection on one dimension of a given cuboid. So here we have on the base cuboid, we want to select slice the data based on the age, and we set the age to be young. So if we do that, we're going to have a what? A three-dimensional array, right? With the age set to young. So the data here shows how the incidence counts of young people over different states and race over different years. Okay, so DICE selects a subcube by selecting on 2 or more dimensions. So to demonstrate that, we can say, okay, we want the young for the age. We want to select a set of states. We're not going to select the entire 50 states. So here we can see our data because we narrowed down our selection. Now our data is a little bit more easier to read. So we have those limited states, and we have the young already set. So we have the data shows race distribution over state across years. And rollup is applying an aggregation function, right? It's by either roll up a concept hierarchy or by collapse dimensions, removing a dimension, for example. So we can use apply functions to achieve roll up. So here we can collapse or remove state and year dimensions. So our data is aggregated along race and age group. Again, we use the sum function to find the total number of incidents. And so let's run this apply. It gave us a two-dimensional array, so race and age group, and everything is aggregated neatly for you. We can also pipe a slice to a roll up to find the number of incidents involving young victims. So here we have, so this is our This is a slice, and then we roll up, right? We slice the original base cuboid, and then we roll up to aggregate data along race and state dimensions. Okay, so let's run that. So now we don't have different age groups, we only have young groups, and see the distribution among race and state. So now we can pause a little bit and examine the apply method. So this is a new usage of apply, slightly different from what we have learned before. Earlier, we learned that this second argument will either be 1 or 2. 1 is rows and 2 represent columns. And what if now we actually give it multiple columns, specific columns? And I want to use this little example to show you how it works. So we can create a matrix, call it test. Our matrix has 2 rows and 5 columns. So this is 1, 2, 3, 4, 5, 6, 7, 9, 10. Okay, so there's 10 numbers. If we apply across 1 is rows, right? Across rows, what do you expect? We would expect 2 numbers because we sum up with everything on this row, right? So the first row sum up to be 25 and second row sum up to be 30. If we apply the same function, sum function, over the columns, what we're going to get? We're going to get a set of 5 numbers, right? So now we're actually doing the summation this way. 1, 2, 3, 4, 5 plus 6, 7 plus 8, 9 plus 10, right? So when we apply over both columns and rows, what are we going to get? We get the original. Our result looks exactly the same as our original data. Why is that? So what apply does, this selection does, is to select the relevant data cells need to be summed up, right? So when we do along rows, the relevant data cells that need to be summed up are those. And when we do columns, the relevant the relevant data cells need to be summed up are those, right? And now if we consider both column and rows, then each summation, each group is actually one data cell itself. Therefore, 1 plus 1 is still 1, and 1 plus 2 is 1, 3 plus itself. So it's still 3. Because here, when we consider those two, the combination of this row and column pointing to one individual value. Therefore, the sum of this individual value is itself, right? So here, when we select race and group, because we're working over on a multidimensional array, when we select this race and age group combination, it's actually forms a group of data. That gave us the aggregation that we are needed. Okay. So that's a short explanation on how apply works when you select multiple columns or rows. This selection defines a group of values that need to be summed up. So the next OLAP, returning to our OLAP discussion, we can look at drill down. So drill down is the reverse of roll up, right? Once you have the data rolled up, aggregated, you cannot find the finer grained value that made up the aggregation, right? Therefore, to demonstrate the effect of drill down, we actually have to return to our original cuboids where we have fine-grained data. And This roll-up operation, the data was aggregated along race and age group dimension. And now in order to perform a drill down for this, for example, adding the age dimension to this, we actually start with the base cuboid and select the race, age group, and year. So this gave us the more detailed lower level data than this operation, where we only care about race and age group, and now we have added a dimension year. Okay. So additionally, we learned in class that we all the base cuboids holds all the detailed data, and all other cuboids are generated from the base cuboid. And this, our apply function demonstrated above should already show you that. So actually this, the result of this apply is a cuboid with 3 dimensions, race, age, and year. And we can run only select the race to get a 1-dimension cuboid. Here you can see how the data are aggregated along the race. So in the entire data set, we have 1,053 incidents involving a Black individual, 71 involves Native American. So this does not aggregate along the race, right? So then how do we get the apex cuboid? Remember, the apex cuboid holds only one value, right? It's the aggregates of the entire data set. So we can do a sum over any 1-dimensional cuboid. So earlier we did race, and now we do year. If you replace year with race, you're going to get exactly the same result. So this sum gave us the base apex cuboid. Okay. The last operation that we demonstrate is pivot. The pivot operation is basically rotating the data to make to present the data in an alternative perspective. Sometimes a different perspective will reveal the information or pattern more clear. So here, this is our 2D cuboid. This apply going to give us this 2D cuboid with state and age group. And if we run that, we'll see that the state is on the rows and the age is on the columns. If we switch the position here when we're selecting them, we achieved the pivot, the rotation. We have a transposed matrix where you can see which one is easier to read. Probably the second one is a little bit easier to read when we have a limited screen space. You can run different combination of this and to see how the orders affects the display. So that is my demonstration on the OLAP operations using multi-dimensional array as the data structure.